8.2c, we're going to be talking about mean absolute deviation, otherwise known as MAD. It is a measure of the spread of data. The higher the MAD, the more the data is spread out. Okay, so this definition is pretty important to understand. Okay. All right, table below shows the 6 fastest birds in the world and their maximum recorded speeds. Okay, so these are all in miles per hour, and here are your 6 birds. Okay, and it says to find the MAD, you must first find the mean. Remember, that's the average speed of the birds by adding all the data and dividing by the sum dividing the sum by the number of values. Okay, so if I add all these up, you should get 663, and we're going to divide it by 1, 2, 3, 4, 5, 6 pieces of data, and that gets you 110.5. That's the mean, that's the average miles per hour of these 6 birds. Okay. Now, step 2, to find the deviation, the distance from the mean for each bird, recall that the absolute value means you are looking for a distance between values. A distance is always positive. Okay, and then we'll calculate the average of the deviations from the mean, okay, known as the mean absolute deviation, or the MAD. Okay, so what we're going to do here is we're going to take the absolute value, these little marks, these straight little, they're like kind of like parentheses, but they're straight. We're going to take the speed for each bird and we're going to subtract off the mean. Okay, so we're going to take this 242 for the peregrine falcon and we're going to subtract off the mean and have that in absolute values. If we do that, that's 131.5. Okay, the right-throated needletail, 105 minus 110.5 in absolute values, and that gets us a 5.5. Eurasian hobby, 100 minus 110.5. Remember, that's absolute value, so that'd be 10.5. Frigate bird, frigate, 95. So we're going to take 95 minus that 110.5. And that gets us 15.5. Anna's hummingbird is 61 minus this 110.5. 49.5. And then the ostrich is 60 miles an hour. And that comes out to be 50.5. Okay, so when you do the difference, when you do these differences, some of them come out to be positive, like in this case. Okay, and it looks like the rest of them come out to be negative. But when you take the absolute value, you're recording all the positive values of that. Okay, this is how far the actual bird's miles per hour speed is from the mean of 110.5, which is the mean of all 6 of these together. Okay, now to take the mean absolute deviation, you're going to add these up and divide by how many there are. We're taking the average of these. So if we add all these up in a calculator, we get 263, and we're going to divide that by 6, and that comes out to be roughly, I think I rounded on that one, 43.83. Okay, so this, what does the MAD indicate? The average distance between each bird's speed and the mean is 43.83 miles per hour. Okay, and we want this number to be the lowest possible number, and that means that the data is less spread out. Okay, if you look at this data, it's pretty spread out. I mean, the lowest is 60 miles an hour and the highest is 242 miles an hour. That data is pretty spread out, so we can expect a higher MAD, okay, a larger MAD, which that is. Okay. Okay, next example. This is with a group of 4 to 5 students, record the number of pens and pencils each of you have. Write down each of the numbers in the table provided below. Find the mean of your data. What does it represent? And then find the mean absolute deviation. Okay, I am going to just write some numbers down from 5 people that I surveyed. Okay, so please note that if we did this, this will vary. If you're watching this video and you're not doing it live in class, this will vary depending on who you survey. Okay, so my data, I surveyed one student and they had 6 pens and pencils, 1 pen and pencil, somebody else, 3, somebody else, 4, somebody else, and 4. Okay, so that's my data after I surveyed 5 kids. Okay, the mean, I am going to add these up, and that comes out to be 18 divided by 5 kids. That gets me about 3.6 is my mean. So this is the average number of pens and pencils from the 5 kids I surveyed. All right, we don't need to worry about the names. Okay, so we're going to be taking each person, the 6, the 1, the 3, the 4, the 4, and we're going to be subtracting the 3.6. So student number 1 had 6 pens and pencils, and we're going to subtract that 3.6. That gives me a deviation from the mean of 2.4. So it's 2.4 pens, pencils away from what the mean is. Okay, student number 2, 1. 1 minus 3.6. Notice that that would be a negative number, so we have to have those absolute values around that. 2.6 is the deviation from the mean. Next, we're going to do 3. And again, we're going to have a negative number, so please make sure you have absolute values around it because it's a distance. And then we've got the last 2 kids had 4. Okay, this wouldn't be negative, but I'm still just going to have my absolute value around that. Absolute value of a positive is still positive. And then the last one is the same as this guy. Okay, now remember the last step is you take the average of these, which means we add them all up, 6.4, and divide it by 5. Okay, so I got a MAD of 1.28. That means that my data's fairly close to one another. There's not a lot of spread. Okay, it's not like somebody said, I don't have any pens and pencils, and somebody else said, I've got 30. Okay, that would be a much larger MAD. Okay, all right. In problem number 6 above, you found the mean absolute deviation for your group's data. On the number line below, mark the position of the mean. Okay, so our mean was 3.6 from this, 3.6. And then it says, put large bracket symbols above and below the mean at a distance of 1 mean absolute deviation. Okay, so if I go 1 away from this, I'll be here and I'll be here. Whoops, let me switch that up. Sorry, guys. Okay, now it says write down the mean and MAD for another group like you did above. Mark the position of the mean on the number line below, put large brackets, symbols above. Okay, I don't have another group, so I'm going to have to skip number 8. Okay, that will vary. This answer will vary depending who you ask. Okay, is the MAD for your group higher or lower than the other group? What does it mean if a group has a higher MAD? Okay, so I'm not going to answer whose is higher or lower because I don't have anybody to compare to, but it's very important to know the higher the MAD, the more spread, can't spell it, spread the data is. Okay, that also means sorry guys, I'm having trouble spelling right now, means more variability. Okay, that is MAD in a nutshell. Thanks, guys.